This is a review on solving linear equations. The steps to solving linear equations are the following. So if you have any grouping symbols, any parentheses, you want to remove any parentheses and combine like terms if possible on each side of the equation. Then if you have any fractions, you're going to clear any fractions by multiplying all terms on both sides by the least common denominator. Then you're going to group like terms on each side of the equal sign. And then you're going to isolate the x term, the variable term, on one side of the equation by adding or subtracting to combine like terms across the equal sign. And then you're going to multiply or divide both sides of the equation by the coefficient of the variable to solve for the variable term, whether it's x, y, whatever the variable may be. And then, as always, you should check your solutions by substituting your answer into the original equation to make sure that both sides are equal to each other. Okay, so let's look at the first one. So notice in the first one, I do have parentheses, so I want to get rid of the parentheses. That'll be the first step. So remember, the distributive property allows you to multiply every term that's inside the parentheses by the coefficient that's on the outside. So remember, I used the word the distributive property. So using the distributive property here, we're going to multiply each term within this set of parentheses by 2. And on this side, we're going to do the same thing, and we're going to do -3. Now be careful. Some students want to say 4 subtract 3 first and then say 1. That's not 1. Order of operations. Remember, order of operations, you have to multiply before you add or subtract. So you got to be careful. You have to follow the order of operations. Okay, so 2 times 3x is 6x, and then 2 times a -1 is a -2, and then plus 3 equal. And on this side, I'm going to get 4. Remember, I distributed the -3. So subtract 3 here means the same thing as adding a -3. So you're multiplying both terms inside the parentheses by -3. So -3 times x is a -3x, and -3 times a +2 is a -6. Okay, now combining like terms. So remember, this is what we do next, combine like terms. All right, so combining like terms on each side of the equation, I have a -2 plus 3 is a +1. So I get 6x plus 1 equals, and over here I can combine these constants. 4 and a -6 is a -2. So I get -3x minus 2. All right, now, next thing you want to do, since this is a linear equation, notice you have variables on both sides and you have constants on both sides. So you want to bring all the variable terms on one side and all the constant terms on the other side. And so that's what this step 4 is. So you want to isolate the x term on one side of the equation by adding or subtracting to combine like terms across the equal sign. So let's deal with the variable that's on this side. So remember, you want to bring this term to the other side. So I need this term right here to end up being a 0 term. So since this is a -3x, I'm going to add 3x to this side. And remember, what you do to one side, you do to the other. So I'm adding 3x to both sides. So notice, what you do to one side of the equal sign, you do to the other side. So you're balancing this equation. And then combining like terms, I have 6x plus 3x is 9x plus 1 equal, and then -3x and 3x, that's 0. And then 0 and a -2 is a -2. Okay, now, remember, we're trying to get the variable term by itself. So I'm adding 1 right now to this 9x. So the opposite of adding 1 is to subtract 1. So I'm going to subtract 1 from both sides. And so when I combine like terms, remember, you're combining like terms quite often, aren't you? All right, combining like terms. So I combine like terms here, I combine like terms here, I combined like terms on this side as well. So quite many places where you're combining like terms. Okay, so +1, -1 is 0. So I get 9x here equal a -2, and a -1 is a -3. All right, and then the fifth step, you'll notice that the fifth step says to get the variable by itself, you're going to divide or multiply both sides by the coefficient of the variable. So the coefficient of x here is 9. So right now I'm multiplying x by 9. The opposite of multiplying by 9 is to divide by 9. So we're going to divide both sides by 9. And then 9 divided by 9 is 1. 1 times x is x. So notice I have x by itself equal. Now remember, you got to reduce. Don't leave it as negative 3/9. So negative 3/9 reduced is a negative 1/3. Okay, so if I did all these steps correct, then negative 1/3 is the solution to this equation. Meaning that if I were to substitute negative 1/3 into the original equation, the left side should equal the right side. So let's go ahead and check. Now on a time test, you normally don't have time to check. So be efficient with your solving techniques and be careful when you combine like terms. So let's go ahead and check this. So I'm going to go ahead and rewrite the original equation. So here's the original equation. 2 times 3x minus 1 plus 3 equal 4 minus 3 times x plus 2. All right, always go back to the original. Don't go back to any of these other equations that you see. Even though they are equivalent, I could have made a mistake somewhere along the way. So always go back to the original. All right, in place of x, I'm going to substitute negative 1/3. So I'm checking to see if negative 1/3 is actually the solution, that I did not make a mistake at all. So 2 times 3 times a negative 1/3. So in place of x, I'm substituting negative 1/3 minus 1 plus 3. And I want to see if this side is going to equal this side. 4 minus 3 times negative 1/3 plus 2. Okay, so let's look at this first set of parentheses right here. So remember, order of operations. You do your grouping symbols first. So 3 times a negative 1/3 is a negative 1. So this right here becomes 2 times negative 1 minus 1 plus 3. And let's just focus on the left side for right now. So 3 times a negative 1/3 is a negative 1. Negative 1 and a negative 1 is a negative 2. So this becomes 2 times a negative 2 plus 3. And I'm going to multiply before I add, order of operations. 2 times a negative 2 is a negative 4. Negative 4 plus 3 is a negative 1. So my left side is equal to a negative 1. Hopefully, the right side is also equal to a negative 1. So let's go to the right side. So remember, you do grouping symbols first. Negative 1/3 plus 2, negative 1/3 plus 2 is 1 and 2/3. 1 and 2/3. So this becomes 4 minus 3 times 1 and 2/3. Okay? Now, you may say, well, how did I get this? Well, remember, that's just arithmetic. You're just adding fractions. So I'm going to go ahead and do that here. Let me read. Okay, so negative 1/3 plus 2, right? So this is a whole number 2. I'm subtracting 1/3 from that. So I'm left with 2/3 from 1. So 1 plus 2/3 is 1 and 2/3. The other way is to find the LCD. So the LCD is 3. Okay, the LCD is 3. So since these denominators are the same, the numerators have to be the same. So negative 1/3 is equivalent to negative 1/3. Now over here, this is the 1. I want this to be a 3. So I got to multiply this by 3, the denominator by 3. Remember what you do to the denominator, you have to do to the numerator. 2 times 3 is 6. So 6 divided by 3 makes sense that this has to be 6 divided by 3 because 6 divided by 3 is 2, and that's what this is. So now I can easily add these two fractions. They have the same denominator. So negative 1/3 plus 6/3 is 5/3, and that's what 1 and 2/3 is. 3, remember, this is a mixed number. Changing a mixed number to an improper fraction, you say 3 times 1 is 3, 3 plus 2 is 5. So I'm going to go ahead and rewrite this mixed number as an improper fraction. So I get 4 minus 3 times 5/3. But 3 times 5/3 is 5. So it becomes 4 minus 5, and 4 minus 5 is a negative 1, and those are equal. So negative 1/3 is a solution to this equation. All right, now let's look at number 2. Number 2. All right, now look at number 2. So number 2, we have, this is still considered a linear equation, even though you see fractions in the denominator, or you see numbers in the denominator, that still makes it a linear equation. The fact that the exponent of the variable x is 1. So notice x to the first, x to the first. The denominator are numbers, and that's fine. So this is still a linear equation. In another lesson, you may have variables in the denominator. In that case, we'll just go ahead and call it a rational equation. Now, for the most part, this is still considered a rational equation because you have rational expressions. 3/2 is a rational number. But let's just, for right now, call this a linear equation. Well, one of the things you want to do, remember, since I do have fractions, is step number 2. So step number 2, you want to clear any fractions by multiplying all terms on both sides of the LCD. Now let's go ahead and do part 1 though. So step 1, so let's go ahead and remove any parentheses. So let's do that first. Notice I have parentheses. See that here? And I have it here as well. Okay, now here's this side is going to be easy. This side, that subtraction right here, may cause some of you a little bit of issue, but listen carefully to the discussion. So in the left side, this is the only set of parentheses I see. So I'm going to go ahead and distribute this 2. So I get 3/2 plus, and in the numerator, 2 times 3x is 6x, and then 2 times 1 is 2, divided by 3, equal 4. Now, there are a couple of things you could do. You could change the subtraction to an addition problem. Some students do, some students don't. I'm going to go ahead right now and just leave it as a subtraction. So I'm just going to bring this down. So in the numerator, right here, I'm going to distribute just to 3. So 3 times x is 3x. 3 times a negative 1 is a negative 3, divided by 2. Okay? So be careful now. So now the other way you could have done this was go ahead and distribute a negative 3, but this would have had to become a plus symbol right here. So that confuses students a little. So that's why I just went ahead and left it as I just brought down the subtraction symbol. Okay, so notice I don't have any parentheses anymore. Okay, and for the most part, I really can't combine any like terms. So there aren't any like terms to combine at this point, the way it looks. So now I'm going to go ahead and clear the fractions. So that's step number 2. Step number 2, let's go ahead and clear the fractions. So we're going to multiply both sides by the least common denominator. So my denominators are 2, 3, and for right now, you can think of this as 4/1. It may help to actually write this as 4/1. So that denominator is a 1, and that denominator is a 2. So the least common denominator is 6. So I'm going to multiply every term by 6. What you do to one side, you do to the other. Okay? So I have this term, I have this fraction, I have this fraction. So consider this as a fraction, consider this as a fraction. Those two are being added together. Consider this as a fraction, consider this as a fraction, and you're subtracting them. All right, so think of it like that. So every term, so altogether I'm counting 1, 2, 3, 4. I'm counting 4 terms. So I'm going to multiply all 4 terms by 6. So here's what you're going to do. You're going to say 6 times 3/2 plus 6 times 6, in the numerator, I'm going to write 6x plus 2 divided by 3, just like this for right now, equal 6 times 4, right? Minus, and then 6 times this term, this fraction, which is 3x minus 3 divided by 2. Okay, so write it like this for right now. All right, now, the whole purpose of multiplying an equation by the least common denominator is to clear your denominators, clear the fractions, meaning that at this point, this denominator better be a factor of 1. This denominator better be a factor of 1. this denominator will end up being a factor of 1. And it does. So let me go ahead and rewrite this over so I'm not writing over there. So I'm just rewriting this step right here. So 6 times 3 halves plus 6 times 6x plus 2 divided by 3 equals 6 times 4 minus 6 times 3x minus 3 divided by 2. All right. And so now what we have is now let's go ahead and reduce. 2 into 2 is 1. 2 into 6 is 3. See, that's a 1 now. 3 into 3 is 1. 3 into 6 is 2. See that? Over here, 2 into 2 is 1. 2 into 6 is 3. Okay, now listen to what I'm about to say next. So I'm going to go ahead and rewrite this over to make it look a little bit better. So 3 times 3, so that's 3 over 1. 3 times 3 is 9, so that's easy to write. So I'm going to go ahead and write this as 9 right now. Plus, now, over here, I'm going to write it this way for right now. So see this 2? It's being multiplied by this expression, okay? So I'm going to need parentheses here. So this right here is this, but all of this is being multiplied by 2. So it's very important you put that numerator, which is more than one term, a binomial, you put that in parentheses, because if you don't, you're probably going to just multiply 2 times 6x and forget to do this 2 right here as well. All right. So if you write like this, you can see you got to distribute. Equal, and that's 24. And then let's do the same thing here. So minus 3 times in parentheses 3x minus 3. Because all of this, every term here, has to be multiplied by 3. Now let's go ahead and distribute. Now remember, order of operations, you need to multiply. That's multiplication right here. The distributive property involves multiplication. So don't say 9 plus 2 is 11. All right, so you're adding before you multiply. Remember, order of operations, you multiply before you add. So I'm going to distribute next and do the same thing here. So I get 9 plus 2 times 6x is 12x. 2 times 2 is 4. Okay, equal 24. And then let's go ahead and distribute the negative 3 here. Negative 3 times 3x is a negative 9x. A negative 3 times a negative 3 is a positive 9. Okay, now combining like terms, see I can easily combine 9 and 4. So I get 12x, and 9 plus 4 is 13, equal a negative 9x, and then 24 plus 9 is, was that 33? 33. Okay. Now at this point, I'm going to bring all the variables to one side, all the constants to the other. So let's get rid of this negative 9x first. So I'm going to add 9x to both sides, because negative 9x plus 9x is 0. But what I do to one side of the equation, I do to the other. And notice I'm aligning my like terms. 12x plus 9x is 21x plus 13 equal 33. 0 plus 33 is 33. Okay, right, and so remember you need to get the variable term by itself, so I need to get rid of this 13. So right now I'm adding 13. The opposite is to subtract 13 from both sides. And then 13 and negative 13 is 0. So I get 21x equal 13, and a negative 33, and a negative 13 is 20. And now dividing both sides by 21, I get 21 divided by 21 is 1. 1 times x is x. I get x to be 20 divided by 21. So if I did all these steps correct, all these steps, if I did not make any mistake, then this should be the solution. All right? And then if you had time, on a test you don't have time, but if you have time, always go back, if possible, if you have time, and check the solution, check this number into the original equation. All right, so let's go ahead for right now. Let's go ahead and do that. So this is going to be a little bit messy because I do have a fraction here, and so let's go ahead and check into the original. Now, at this point, you may want to use a calculator to help you. So I'm going to take my calculator out, because doing this by hand is going to take a while. So let's go ahead and use the calculator to help us with this. So let me go ahead and use another sheet of paper. Okay, so I'm going to write this original problem over. So we're checking x equal 20 divided by 21. So I get 3 halves plus 2 times 3x plus 1 divided by 3 equal 4 minus 3 times x minus 1 divided by 2. So in place of x, I'm going to substitute 20 divided by 21. So I get 3 halves plus 2 times 3 times x, which I'm saying is 20 divided by 21, plus 1 divided by 3 equal 4 minus 3 times 20 divided by 21 minus 1 divided by 2. All right, at this point, we're going to use a calculator. So I'm going to do inside the parentheses first. I'm using my calculator. So I'm going to say 3 times 20 divided by 21, 3 times 20 divided by 21, and then I'm going to add 1 now, plus 1 equal, so I have this decimal. Don't leave it as a decimal because this does not terminate, so don't approximate. So make sure you know how to use your calculator in terms of changing this to a fraction. So I'm changing this to a fraction. So I'm going to say second PRB here, and then press equal. And so this is 3 and 6/7. So 3 and 6/7. That's what this is. So this right here is 3 and 6/7. Okay? And I'm going to go ahead and write this as an improper fraction. So 3 times 7 is 21. 21 plus 6 is 27/7. All right, so that's what this is. So I get 3 halves plus 2 times 27/7 divided by 3 equal, and let's go ahead and do the same thing here. So it'll be 4 minus, all right, so 20, now this one's easy for y'all to do in your mind. You don't need a calculator because look, 20 minus 20 divided by 21 minus 1. Well, y'all know that 1 is the same thing as 21 divided by 21. So 20 over 21 minus 21 over 21 should be a negative 1 divided by 21. So this would be minus 3 times a negative 1 divided by 21 divided by 2. If you didn't see this, use your calculator. So 20 divided by 21 minus 1 equals, now you get this decimal, so go ahead and change it to a fraction. So I get, as a fraction, this becomes negative 1 over 21. Okay, now let's go ahead and multiply this out and then divide by 3. So I get 3 halves plus, all right, so here's what I'm doing. 2 times 27 divided by 7, so 27 divided by 7, I'm going to press equal. So that's my numerator. But I can divide by 3, press equal. All right, so I'm going to change this decimal. So this decimal represents this fraction right here. So I'm going to change that to a fraction. So I'm going to say second PRB equal, and I get 2 and 4/7. So I'm going to write 2 and 4/7 here. And then I'm going to change this to an improper fraction. 7 times 2 is 14. 14 plus 4 is 18. So this is 18 over 7. So I get 18 over 7 here. And then over here, I get 4 minus. All right, so this is going to become 3 times a negative 1 divided by 21. So 3 times, I'm going to put this in parentheses since that's a negative, and I don't want to mess this up. So 3 times negative 1 divided by 21, parentheses, equal, divided by 2, equal, so I'm going to change, so this fraction represents this decimal, so I'm going to change that to a fraction, and I get negative 1/14. So 4 minus a negative 1/14, okay? All right, now let's use a calculator for this. So 3 halves, so 3 halves, so 3 divided by 2, I'm trying to get the glare out of the way, 3 divided by 2 plus 18 divided by 7, press equal. So let's change that to a fraction. And when I do that, I get 4 and 1/14. So 4 and 1/14. So let's see what this is. Oh, well, look. So subtract a negative means adding, right? So that's 4 plus 1/14. and 4 plus 1/14 is 4 and 1/14, and those two are equal. So notice using a calculator here made things a lot quicker for us to check. If you were doing this by hand, you would still be having to find the least common denominator and then going in there and being very careful along the process. So sometimes it's efficient at this point in the process to just use a calculator as an aid. Okay? All right, so those were two problems to help you to understand how to solve linear equations that involve parentheses and fractions. So now remember, this was just a review, so make sure you're actually going through the lessons to look at the further development of the process of solving linear equations. All right, so this will be the end of this review.